Hello everyone, in this video we are going to see about some of simple cubic and BCC structures and their characteristics. In this video we have to discuss about the coordination number, atomic radius of simple cubic and body center cubic. From that we have to calculate atomic packing factor. From that, after that, finally we have to discuss some of the main application of calculation of atomic packing factor and connection with the real world applications. So why need to study APF, about APF, that is atomic packing factor. You can see the picture is, it is all about the structure property relations. So atoms in a crystalline will packed in a different manner. One is loosely packed and densely packed. According to the densely packed area, the physical properties of the material, the crystalline material will be changed. According to that, electronic conductivity increases, whereas increasing the crystal density. Similarly, whereas the ionic conductivity decreases with this increasing in the crystal packing density. These are the pictorial representation of the behavior of physical properties, and the atomic packing factors that is indicated by the deity packed with the green and yellow color dots the atomic positions, that is lattice points, lattice arrangement, that is loosely packed and densely packed. So electrical conductivity and any mechanical behavior are all related with this packing density of the atoms. So you can see the next we have to see some of the characteristics parameters for the finding the atomic packing factor or packing density of that simple cubic and BCC structures. At first we have to calculate that number of atoms per unit cell. Next we have to calculate that the coordination number. Third one is we have to calculate atomic radius. So it is the atomic radius is nothing but the half of the distance with the nearest neighboring atoms. Coordination number is nothing but the main the atoms the closest atom of a particular atom in the particular unit cell, that is the nearest neighboring atom of a unit cell of any atom of a particular unit cell is what is the numbers which is connected to the particular atom. This is called as the coordination number, that is the nearest neighbor atoms in the particular unit cell. So for a simple cubic structure about 6. So you can see that next we have to see the images. You can see that you can easily calculate with this pictorial representation. There is a regular dot to the unit cell, BCC structures unit cell. According to that, the atom highlighted, the marked highlighted in a red color, that shows that 6 neighboring atoms to that particular atom. That will be a coordination number will be a 6. From the atomic unit will be atomic number of atoms per unit cell is 1. So cubic cell have a 8 corners in the 8 atoms. So each atom shares that 8 unit cell nearby unit cell, so that 1 to the 8 of the portion will be covered in that particular unit cell. So the number of atoms per unit cell will be 1. From that we have to calculate atomic packing factor, that is the volume of all atoms present in the unit cell to the ratio to the volume of total volume of the unit cell. From that we have to calculate the derivation. Atomic packing factor is about 52%. Is 0.52 fraction, is we convert into the percentage, 52%. So 50% atoms will occupy the simple cubic structures, unit cell structure. Remaining 48% will be the empty space. So you can see that atomic arrangement. So this is a cutoff mark of atomic cutoff image of the atoms present in the unit cell. You can see that every atom cutted in a different manner. So atoms in the corners having that sharing the radius about half of that unit length along the A and B, A, X, Y, Z direction, that is A, B, C. So only equal to atomic radius equal to A by 2. Similarly, we have to go for that simple body center cubic structure. You can see that the pictorial representation of a body center, there is an atom similar to that simple cubic structure. There is an atom inside the center of the cubic cell in addition to the center of that particular unit cell, that will be a body center cubic. Here we connect the atomic radius in different manner. We have to connect the central atom and making the rectangle triangle. We have to calculate that atom present in the unit cell. From that we have to calculate the atomic radius about root 3a by 4. This is a cutoff image of the atoms present in the simple cubic structure. So coordination number will be 8. So one of the center atom will be connected to the all diagonal and all the corner atoms in the unit. So that will be coordination number of the body center cubic. From the APF calculation we have to calculate 68% of atom occupy the body center cubic structure. So remaining portion will be the empty space. So one of the main applications. So if we compare that, SCC is greater than that of BCC, having the packing density. Okay. So what is the main application is the application of is about semiconductor industry. So atomic application packing factor is used for semiconductors to calculate the atomic radius and some of doping level and electronic conductivity on based on that atomic packing density. And material science, we have to some of the brittle nature and ductile nature will be calculated by that this atomic packing factor. The X-ray diffraction also, X-ray according to the atomic density, the X-ray diffraction patterns also differs. From that we have to calculate the atomic structure calculations. Okay, here we see some of the you can show that some of the reference for your study or further references. Go for the study. So thank you. In this video I have stop here. Next video we have another interesting topic. Thank you.